All right, we're going to continue with the second part of chapter 1.4a. All right, the second half of this lesson, we're going to solve quadratic equations using square roots. Now, the only way that these are different than what we did before is you don't have an x term, right? And then you'll see what that means when we look at the examples. But the goal here is when you don't see an x term, you only see something squared. The goal is to isolate whatever is squared and then square root both sides of the equation, putting a plus or minus in front of the root. This is a super important step that a lot of people forget, just because if I give you something like x squared equals 4, right, think about what we can plug into that x for this to be a true statement. All right, the first thing to come to people's minds is 2, right? 2 squared, of course, is going to get you 4. All right, but 2 is not the only thing that we can square to get a 4, right? If we square negative 2, right, negative 2 squared is also a positive 4. So that's why when we solve something that has an x squared, right, the opposite of squaring something is a square root. So I can take a square root and then I get x equals positive or negative, plus or minus, whatever the square root is. Right, so plus or minus 2, right? And that's the goal in these kinds of problems. All right, so let's start with that first one. So I have something like x squared equals 9. And again, look at this entire page. Notice that I only see x squareds, but I don't see an x term, right? So this isn't the same as something like x squared equals 9x, right? I don't see an x. I only see something squared, and I only see a number, right? When this is the case, I want whatever is squared on one side of the equation, and I want the number on the other. In this case, it is. All right, so I can square root both sides once I have this step done. All right, so that'll be the first thing that I want to check for is I want x squared equals something. And then the second thing I want to do is square root both sides. All right, so we got x squared by itself, square root both sides, the x squared and the square root are going to cancel. So then I get x equals, the square root of 9 is 3, but I can't just say x equals 3. This has to be a plus or minus, positive or negative. And we do get two answers, right? When you put your answers in WebAssign, for example, it's going to have you write them as two separate answers, and you would write x equals 3, comma, negative 3, right? I have two separate answers. All right, and that's always how it's going to work in these kinds of problems. All right, so I'll try the same thing with the next one. So something like number 14. Again, I have the x squared equals a number. All right, that's already done for us. So I can go ahead and square root both sides. So square root, and then the square root and the square are going to cancel. I get x equals, it's not just going to be the square root of 15, it's going to be positive or negative. All right. Now, 15 is not a perfect square, but we want to check if it can be broken down any further, right? This one cannot, right? The only factors of 15 are going to be 3 and 5, right? And neither one of those are perfect squares, right? There's also 1 times 15, but we don't really want to use 1. That's a little redundant, so we can just leave it just like this. Right? Sometimes you do get radical answers. All right. Now, the difference between the next two that we're going to do versus the ones that we just did is that these are not in the form that we want it to be in, right? Again, you see the x squared, but I don't see any x term at all in this equation, right? I'm looking at number 15. I see an x squared, but I don't see an x. I want the x squared by itself, so that way we can square root both sides, right? In this case, I don't have x squared equals something. I have x squared minus 48 equals 0. So I want to add the 48 on both sides. So plus 48 plus 48. And then negative 48 and plus 48 go away. And then I get x squared equals 48. All right, and then I can square root both sides. And so I get x equals positive or negative square root of 48. All right. And again, 48 is not a perfect square, but we can check, right? A lot of people, what they do with 48 is they maybe say that this is 6 times 8 or 4 times 12. All right, I'll go with what most people would say, maybe something like 4 times 12. All right, that's fine. You would just have to keep breaking it down, right? If we remember our factor tree, and then we can break down 12 to maybe be 4 and 3. I don't really need to break down 4 and 4 anymore because they already match, right? I have a 4 here and a 4 here. If you kept going, right, this goes back to way back in the beginning of the school year when we were simplifying radicals, right? I could break those down into 2 and 2, and then 2 and 2, and then I would get 2 pairs of 2s, which would still get you a 4, all right? But don't really worry about that, right? If you recognized it from here, that's fine. So the square root of 48, my pairs are going to be a 4, so then I get x equals positive or negative 4, and then I have a 3 left over underneath the radical. All right, so you always want to make sure your answers are simplified fully. All right, and then I can look at number 16 and do the exact same thing. Again, with these kinds of problems, I see the x squared, but I don't see an x. So I for sure want an x squared equals something. All right, and so to get that, I'm going to add 43 on both sides. And so I get x squared equals 43. And then I can square root both sides, and then I get x equals plus or minus the square root of 43. All right, and I can't simplify the square root of 43 anymore, so I just leave it alone. All right, now I want to show you guys some different cases that you might see, right? Maybe you're not always going to see just x squared, right? Sometimes it's going to be an expression squared, right? When this happens, no matter if it's just x or if it's an entire expression, you still want that by itself. All right, so if you look at number 17, I have x minus 2. All of that is squared. This is my squared term, and it is on one side of the equation already, and then I have my number on the other side. All right, so then I can do the exact same thing as before. I would just have to square root this entire expression. All right, and then when you do that, the square root and the square go away, and so I get an x minus 2 equals positive or negative square root of 28. All right, the only difference here is that we would need an extra step to get the x by itself, and it would be to add 2. All right, add 2 to both sides, and I get x equals 2 plus or minus positive or negative the square root of 28. Now again, keep in mind you cannot combine a radical with a whole number, so you would leave it alone just like this. The only extra thing we would want to do is break down 28. Right, keep in mind factors of 28 are going to be 4 and 7. You can break down 4 to be 2 and 2. And then 2 is my pair, so it's going to be x equals 2 plus or minus 2 square root of 7, right? 7 was our leftover. And then this would be your final answer. All right, so they get a little uglier, the answers. Doesn't mean you did anything wrong, just means you have some strange radical answers, right? There's nothing wrong with that. All right, and we'll try the same thing with number 18. Again, I have something squared, so this entire thing is raised to the second power. So to undo that, I can square root both sides, right? The square root and the square are going to cancel out. And so I get an x minus 5 equals plus or minus the square root of 25. All right, and then to get the x by itself, we would just need to do one more step, is to add 5 on both sides. And so I get x equals 5 plus or minus the square root of 25. All right, now you can simplify this a little more, right? Square root of 25, this is a perfect square. So then this is going to become x equals 5 plus or minus 5. All right, and then plus or minus 5, you also don't want to stop here, right? Because what does plus or minus mean? Well, it means just that. It means 1 is plus, 1 is minus. So I'm going to split this up into 2 different expressions, right? So one of them is going to be a 5 plus 5. The other one is going to be a 5 minus 5, right? I'm able to do it here and not before because this time we do have whole numbers that we're able to combine. So one of my answers is going to be 5 plus 5, so 10. My other answer is going to be 5 minus 5, which is 0. All right, so again, just to make this distinction clear, right, we have 2 whole number integer answers, right? So 10 and 0. Over here, I have 2 plus or minus 2 square root of 7. Even if I did split it up, I could have said that this is 2 plus 2 square root of 7, and this one's 2 minus 2 square root of 7. All right, there's nothing wrong with saying it like that. You can write your answers separately. All right, but there's really no extra benefit to it because there's nothing further we can do with it. I cannot add 2 plus 2 square root of 7, and I can't do 2 minus 2 square root of 7. All right, so there's nothing more I can do with those. Those are going to stay exactly as they are. All right, so hopefully that distinction's clear. All right, let's try the same thing with number 19. Again, I have something squared. This whole thing is squared, and I have a number on the other side. So I can go ahead and square root and square root. So this is going to be a 4x plus 1 equals plus or minus the square root of 20. And then now we need 2 steps to get our x by itself, right? I would then need to subtract 1 on both sides, and so I would get 4x equals negative 1 plus or minus the square root of 20, and then divide both sides by 4. And so I get x equals negative 1 plus or minus the square root of 20 over 4. All right, very last thing you want to do is check if you can simplify the square root of 20. So factors of 20 are going to be, you can pick anything, but maybe you pick 2 and 10. Right, and then 10 you can split up into 2 and 5. And then I have my pair of 2's. All right, so then we get x equals negative 1 plus or minus 2 square root of 5 over 4. All right, so not a pretty answer at all. Maybe not something that you guys are used to, but these are possible answers, right? You do get answers, they just are not as pretty, and they're radical answers. All right, but let's try the same thing with the next one. All right, once again, if I have something squared and a number on the other side, I can go ahead and square root both sides of the equation. So square root, the square root and the square cancel out. And so I get a 4x plus 7 equals plus or minus the square root of 44. All right, and then again, 2 steps to get your x by itself. I'm going to subtract 7 on both sides. And so I get 4x equals negative 7 plus or minus the square root of 44. And then lastly, I'm going to divide both sides by 4. All right, and so I get x equals negative 7 plus or minus the square root of 44 over 4. Now, once again, you do want to break up 44 and see if you can simplify it anymore, right? I can do 4 and 11. And then 4 I can split up into 2 and 2, and so I get 2 as my outside of my radical, and then 11 underneath. So then my answer, my final answer is going to be x equals negative 7 plus or minus 2 square root of 11 over 4. All right, again, not pretty answers, nothing that maybe you guys are used to, but these are valid answers that we get in these kinds of problems. All right. All right, so that's this page. And then lastly, maybe some other things that you might see are maybe there are numbers in front of your x squared. All right, all we have to do in these cases, so I'm going to start with number 21. All we have to do is, once again, we're trying to get x squared by itself. So I'm going to go ahead and I'm going to divide everything in number 21 by 9. Right, I want the x squared by itself, and I do want this by itself just because I don't see an x term, right? I only see x squared and numbers. So I can get the x squared by itself, divide by 9, and so I get x squared equals 36 divided by 9 is 4. And then we're just solving this equation, right? So I get x squared equals a number. I can square root both sides, and then I get x equals plus or minus the square root of 4 is 2. So I get this as the final answer. All right. Now again, same thing with the next one. 25x squared equals 37. I want the x squared by itself. I don't see any other x's or anything, so the best way to go about it is to divide everything by 25 and get the x squared by itself. All right, so divide by 25, and then I get x squared equals 37 over 25. All right, that doesn't simplify at all, so I can go ahead and square root both sides. And so I get x equals plus or minus the square root of 37 over 25. All right, we don't want to leave our answer like this. We always want to split it up. Even if the bottom is not a perfect square, you do want to split it up just to see if it's not a perfect square, you want to rationalize the denominator. All right, but in this case it is. All right, in this case I get x equals plus or minus the square root of 37 over the square root of 25. And the square root of 25 is 5. So I get x equals plus or minus the square root of 37 over 5. All right. So let's try the same thing with the next one, number 23. Once again, you want to get the x squared by itself. In this case, not only is there something in front of the x squared, there's also a minus 16 on the same side of the equal sign. So to get the x squared by itself, I want to add 16 to both sides. So then I get a 3x squared equals 16. And then divide both sides by 3. And so I get x squared equals 16 over 3. And then once again, I can square root both sides. And so I get x equals plus or minus the square root of 16 over 3. Once again, you always want to split up the radicals. So it's going to be x equals plus or minus the square root of 16 over the square root of 3. Now the square root of 16, that's going to become 4, whole number 4, but I still have a radical in the bottom. All right, to get rid of that radical in the bottom, we can multiply the top and the bottom by the square root of 3. All right, so anytime there's a radical on the bottom, we want to rationalize it. So I get x equals, on top, I get 4 square root of 3. And on the bottom, I get square root of 3 and square root of 3, which is the whole number 3. All right, and then plus minus. All right, always plus minus. All right. So then I can do the same thing with number 24. All right, to get your x squared by itself in this case, I want to divide both sides by 7. And so I get x squared equals 15 over 7. And then I can square root both sides, and so I get x equals plus or minus the square root of 15 over 7. But again, you can split this up. This is going to be x equals plus or minus the square root of 15 over the square root of 7, and then you want to rationalize the denominator, so it's going to be times the square root of 7 and times the square root of 7. All right, and then on top, 15 times 7 should get you the square root of 105. You can do that off to the side if you need to. 15 times 7, all right, should get you 105. All right, over square root of 7 is just 7, all right, and always a plus minus in front of it. And that's your final answer. You can check if you can simplify the square root of 105, but I don't know, let's say you did, then we know for sure that that's 15 times 7, and then 15 is going to get you a 3 times 5. There's nothing that shows up twice, right? So I can't really do anything to simplify the square root of 105, so I could just leave it just like this. It's going to be a radical on top, whole number on the bottom. All right, but that's really it for this lesson. This is kind of the start of where you get stranger answers, but a lot of times with these quadratic equations, we teach you different methods so that way you can handle these strange answers, right? And you'll see next lesson when we do completing the square, and then the one after that when we do the quadratic formula, you get really nasty looking answers, right? So it's better to get familiar now early on, right? Because that's most of what you're going to see moving forward.